video, I'm going to show you lots of quadratic exam questions. If any of them are too difficult, just have a look at the caption below and there are links to my other videos that go into a bit more detail in each of the individual topics. In the first exam question, we have to solve the equation 6 root y plus 2 over root y minus 7 equals 0. So what I'm going to try and do is make a substitution so that I can rewrite this equation in a simpler looking way. And the substitution I'm going to make is root y is equal to the letter t. Okay, so I'm going to replace both of these root y's with the letter t instead. So if I do that, the equation will become 6t plus 2 over t minus 7 equals 0. And straight away, this equation is looking a lot simpler to solve, okay? So what I would do next if I was trying to solve this equation here is I would get rid of this fraction. So to do that, I'm going to multiply everything in this equation by the letter t. Okay, so if I multiply 6t by t, I get 6t squared. If I multiply this fraction by t, the t's cancel and I'm left with 2, so now I have got rid of that fraction. And if I multiply negative 7 by t, I get negative 7t. Okay, so now we have a quadratic equation to solve, okay, to find the letter t. So you could use the quadratic formula to solve this equation, or in this one I'm going to factorize, as I can factorize this one. So I'm going to put that quadratic into double brackets. So in one bracket I have 2t minus 1, and in the other bracket I'm going to have 3t minus 2. Okay, so now that it's factorized, I can find my values of t. If I consider the first bracket equaling 0, so 2t minus 1 equals 0, that would give me a value of t of positive a half. Okay, so there's the first value of t. Next, if I consider this bracket equaling 0, so 3t minus 2 equals 0, that would give me a value of t of 2/3. Okay, so we've solved this quadratic equation to find two values of t. But remember, we're solving an equation to find the values of y. Don't forget we made that substitution at the beginning, so we have to remember to switch back at the end. So remember, t is actually the square root of y. So you need to switch your letter t back to the square root of y. So let's take this value here first. So instead of t equals a half, I have the square root of y equals a half. And if we take this one here, instead of t equals 2/3, we have the square root of y equals 2/3. So we have to solve both of these equations to find the two values of y. So if I want to get rid of the square root symbol, I have to do the reverse of square rooting. I have to square. So if I square a square root, it just cancels to leave me with y. And if I square a half, I square the numerator and then I have to square the denominator, I get a quarter. So that's the first value of y. Now we need to do the same thing with this equation. So I'm going to square both sides. So when I square the square root of y, I'm just left with y. And if I square 2/3, I have to square the numerator, square the denominator, so I get 4/9. And there we have it. We've solved the equation to find the two values of y. In the next exam question, it says find the set of values of n for which the straight line y equals mx plus 1 and the curve y equals 3x squared plus 2x plus 4 intersect at two distinct points, okay? So we have a curve and a straight line, they're intersecting at two distinct points. So it looks something like this sketch here. So whenever a straight line and a curve intersect at two distinct points like this, we know that the discriminant has to be positive. So b squared minus 4ac is going to be greater than 0. So we have to try and work out the discriminant, then we put it greater than 0, so we form an inequality, and then we're going to solve this inequality to find the values of n, okay? So in order to find the discriminant, we have to find our equation, and to find our equation, we have to solve the simultaneous equations here of the straight line and the curve, okay, to find the points of intersection, okay? So they're both already rearranged so that y is the subject. So since y is equal to y, we know that mx plus 1 has to equal all of this here. So I'm going to write that down first. So mx plus 1 equals 3x squared plus 2x plus 4. So remember, your equation here has to equal 0 before you can pinpoint your values of a, b, and c and then work out the discriminant. So I'm going to move mx plus 1 over to the right hand side so that I have 0 on the left hand side of the equation. Remember, when these terms move across the equal sign, they change sign, so they're both going to change to negatives. So I now have 3x squared plus 2x minus mx, and if I subtract 1 from 4, I get 3. Okay, now in my next step, I'm just going to factorize the x terms here so that I can isolate the value of x and find my value of b a little bit more easily. So 0 is equal to 3x squared plus x, and then inside the brackets, if I factorize, I'm going to have 2 minus m plus 3. So if I can now write down my values of a, b, and c, they would be a is equal to 3, b is equal to everything inside the brackets, so 2 minus n, and c is always the constant, so the part without x, so 3. Okay, remember a is always the coefficient of x squared, so whatever you're multiplying x squared by, b is always the coefficient of x, so whatever you're multiplying x by, and c is always the constant. Okay, so now we've got our values of a, b, and c, we can work out the discriminant, b squared minus 4ac. Okay, so that's what I'm going to do next. So instead of b squared, we're going to replace it with 2 minus m all squared. Then we've got minus 4, and we're multiplying it by a, which is 3, and we're multiplying by c, which is also 3. Okay, so now I'm just going to expand and simplify the discriminant. So if I expand these brackets here, I'm going to get 4 minus 4m plus m squared. And if I times these three numbers together, minus 4 times 3 is minus 12, and if I times that by 3, I get negative 36. Okay, one more step to simplify. So I've got m squared minus 4m, doesn't change. And then if I do 4, take away 36, I'm left with negative 32. So this is the discriminant. Okay, so we've worked that out. Remember at the beginning, I said the discriminant has to be positive because the straight line and the curve intersect in 2 distinct points. Okay, so if it's positive, we need to put it greater than 0. So we're solving a quadratic inequality. M squared minus 4m minus 32 has to be greater than 0. So what I suggest you do when you're solving quadratic inequalities is consider this as a quadratic curve, okay? If you were going to work out where this quadratic intersects the x-axis, you would put it equal to 0 and you would solve this quadratic equation. So you can either use the quadratic formula or this one, I think you can factorize it. If I factorize, I get m in here, and then this should be negative 8 and positive 4. So I can see my values of m should be positive 8 and negative 4. So if this is a quadratic, it would intersect the x-axis at positive 8 and negative 4. Okay, so there's my sketch to help me solve the inequality. Now the inequality says that this quadratic is greater than 0. That means we're interested in everything above the x-axis. Okay, I'm just going to shade it in bold. So that's the part that we're interested in. Had the inequality sign been the other way around, so smaller than 0, we would have shaded everything underneath the x-axis. Okay, so it's greater than 0, so it's these parts that we want to find the values of m for. So remember, these are the values of m down here. So m is 8 and m is minus 4. If you think about the values as you move to the right along the x-axis, they get bigger. So all the values of m as I travel along this line on the shaded part are greater than 8. So that's the first part of our solution. M is greater than 8. Then if you look on the other side and you go to the left, Well, they would be all the values that are smaller than -4. Okay, so our solution to this question is m is greater than 8 or smaller than -4. In the next question, it says the equation of a curve is y equals 2x squared plus m multiplied by 2x plus 1, where m is a constant, and the equation of a line is y equals 6x plus 4. Show that for all values of m, the line intersects the curve at two distinct points. Okay, so we have the curve and the line intersecting at two distinct points. So whenever that's the case, we know that there are two solutions, and so the discriminant is going to be positive. So b squared minus 4ac is going to be greater than 0. So what we need to try and do is solve these simultaneous equations to find the points of intersection, and using that equation we can work out the discriminant, and hopefully we can prove that the discriminant is always positive, and that would show that there are two distinct points, okay? So if I'm going to solve the simultaneous equations here of the curve and the straight line, they're already rearranged to make y the subject. So if y is equal to y, we know that 6x plus 4 has to equal all of this. So I'm going to write that down first. So 6x plus 4 has to equal 2x squared plus m, all multiplied by 2x plus 1. Alright, now I need to rearrange the equation so that it's equal to 0, so I can identify my values for a, b and c more easily for the discriminant. So I'm going to move these terms here over to the right hand side. So I'm left with nothing on the left hand side of the equation. Remember, when these terms move across the equal sign, they're going to change signs, so they're both going to become negative. So I have 2x squared plus m all multiplied by 2x plus 1, and then I'm subtracting 6x and subtracting 4. Okay, next it would be a good idea to just expand these brackets and simplify if possible. So let's see what happens if we do that. So if I expand these brackets here, m multiplied by 2x is 2mx, and m multiplied by 1 is m. And this part just stays the same for the moment. Okay, so I can't actually simplify, but what I'm going to do is I'm going to group the x terms together and the constants, so just write them next to each other first. So I've got the 2mx minus 6x together and the m minus 4 at the end, okay? So now I'm just going to factor out the x. I'm going to factorize these terms here, okay? As then it will help me find the value of b that I need for the discriminant a bit more easily, okay? So if I factorize those terms, putting x at the front, inside the brackets I should have 2m minus 6, and this part is just staying as it is. Okay, so remember, a is always the coefficient of x squared, so a is equal to positive 2. b is the coefficient of x, so b is equal to everything inside the bracket, so 2m minus 6. And c is always the constant, the part without the x, so this part at the end, c is going to be m minus 4. Okay, so now we've got our values for a, b and c, we can work out the discriminant, which is b squared minus 4ac. So instead of b squared, I'm going to write 2m minus 6 all squared. Then I've got to minus 4 and multiply that by 2, which is a, and then c, which is m minus 4. Okay, I'm running out of room, so I'm just going to carry on up here. So this is our discriminant, but I'm just going to multiply the brackets and simplify. So if I expand these brackets here, so multiply them by themselves, I get 4m squared minus 24m plus 36, okay? And then here, if I times minus 4 by 2, I get minus 8. If I times that by m, I get negative 8m. Then if I times the minus 8 by minus 4, I get positive 32. So now I can simplify. So there's only one m squared term, so that part stays the same here. Negative 24m, take away another 8m is going to be negative 32m. And then if I add 36 to 32, I get 60m. 8. Okay, so this is the discriminant. And remember, if this is positive, it will show us that there are two distinct points. Okay, so we want to try and show that this is always going to be positive. Okay, so we want to show that the discriminant is always greater than 0. Okay, this is what we want to prove. So what I'm going to do first is I'm going to divide everything by 4. Okay, I think all of these numbers are divisible by 4. So n squared minus 8n plus 17 is greater than 0. Okay, so this here, this quadratic, can be written in a different form. We can complete the square and rewrite this in square brackets. Okay, so if I complete the square, I'm going to have m minus 4 in square brackets. Then I have to subtract 16 and then add the 17. And this will simplify to m minus 4 all squared. And if I add these together, I get 1. Okay, so all I've done to get from here to here is I've completed the square. Alright, so now it's in its completed square form. We've proven that it's always going to be positive. Remember, these square brackets can never be negative because they're being squared. If you had a negative number within the brackets, when you square it, so times it by itself, it would become positive. So this can never be a negative number, okay? The smallest these square brackets can ever be is 0. So if the smallest this can be is 0, and then we're adding 1, we know that the left-hand side, 1, is always going to be greater than 0. Because this is either going to be 0 or something bigger than 0, so it's only going to get bigger. So the smallest the left-hand side of the inequality can ever be is 1. Okay, so we've proven that the discriminant, written in its completed square form, is always greater than 0. So when the discriminant is greater than 0, we know the straight line and the curve intersect at two distinct points. Okay, so that's how you show for all values of n, the line and the curve intersect in two distinct points. In the next question, it says the equation of a line is y equals mx plus c, where n and c are constants, and the equation of a curve is xy equals 16. In part A, it says, given that the line is a tangent to the curve, express n in terms of c. So this part here at the end maybe looks a little unfamiliar, but we do know that when a line is a tangent to the curve, there's one intersection point, one solution, and so the discriminant is equal to 0. So b squared minus 4ac will equal 0 in this question. Okay, so if we're trying to work out that point of intersection of the straight line and the curve, we need to solve the simultaneous equations. And when we form that first equation, from there, we can calculate the discriminant. And then if we put it equal to 0, we form an equation that we can hopefully rearrange to express n in terms of c. So let's have a go. So this equation has y as the subject. So I want to rearrange this equation so that y is the subject as well. So I'm going to divide by x so that y is equal to 16 over x, okay? So now that both equations, here and here, have y as the subject, I can put mx plus c equal to 16 over x. Okay, so I'm going to write that down first. So mx plus c is equal to 16 over x. Alright, so first I want to get rid of this fraction here, so I'm going to multiply everything in this equation by this denominator x. So if I times by x here, I get mx squared. If I times c by x, I get cx. And if I times this by x, the x is cancelled and I'm left with 16. Now, I need to move this 16 over to the left-hand side so that the equation equals 0. So that mx squared plus cx minus 16 equals 0, as now I can identify my values of a, b and c a lot more easily. So a is always the coefficient of x squared, so a is equal to m. B is always the coefficient of x, so b is equal to c. And c is always the constant, the part without the x, so here it's negative 16. So now, with our values of a, b, and c, we can work out the discriminant. So b squared minus 4ac. So if I replace b, a, and c in this expression, instead of b squared, I'm now going to have c squared. Then I have to minus 4 and multiply by a, which is m, and c, which is negative 16. Okay, so I'm just going to carry on up here. And I'm just going to simplify this. Okay, so c squared is going to stay the same. Then if I expand these brackets, I have negative 4 times m, which is negative 4n. And if I multiply negative 4m by negative 16, I'm going to get positive 64. Okay, so this is this discriminant. And remember we said at the beginning, this has to equal 0 because the line is a tangent. Now, I feel like I missed something. Oh yes, I forgot to write down the n here. Remember, it was negative 4n times negative 16 is positive 64m. I forgot to write down n. Okay, so this is our discriminant. It's equal to 0. Now, when it says express m in terms of c, it means rearrange to make m the subject. So you need to have m equals and then everything that's not m on the other side of the equation. So I'm going to subtract c squared on both sides. So that 64m is equal to negative c squared. Next, I'm going to divide by 64. So m is equal to negative c squared over 64. And that's it for part A. So in part B, it says, given instead that m equals negative 4, find the set of values of c for which the line intersects the curve at 2 distinct points. So if m is equal to negative 4, that's going to change the equation of the straight line. So now it's going to look like this. Y is equal to negative 4x plus c. And the equation of the curve here, y equals 16 over x, is the same as before. Okay, so there are 2 equations. So this time, the line intersects the curve in 2 different places, so like so. So we can see there are 2 different solutions, 2 roots, and when that's the case, we know that the discriminant has to be positive. So b squared minus 4ac, this time, has to be greater than 0. Okay, so we're going to solve our simultaneous equations. Then from the equation that we find, we can work out the discriminant. And this time we're going to form an inequality, put it greater than 0, and then we can find the set of values of c. Okay, so if I'm solving the simultaneous equations here, they're both organized so that y is the subject. So I know that minus 4x plus c has to equal 16 over x. So I'm going to start by writing that down. So minus 4x plus c equals 16 over x. Okay, so first I want to get rid of this fraction here. So I'm going to multiply everything in the equation by the denominator x. So if I times negative 4x by x, I get negative 4x squared. If I times c by x, I get cx. And if I times this fraction by x, the x cancels and I'm left with 16. Now I'm just going to move the 16 over to the left-hand side so that the equation is equal to 0. So now I can choose my values a, b, and c. So a is in front of the x squared, so a is negative 4. B is in front of the x, so b is equal to c. And c is the constant at the end without the x, so c is equal to negative 16. So remember, the discriminant is b squared minus 4ac. Okay, so this is what we're trying to work out. So if we look down here, our value of b is now equal to c, so we've got c squared. Then we've got minus 4, and we're multiplying by a, which is negative 4, and c, which is negative 16. Okay, now I'm just going to work out what this comes to. So negative 4 times negative 4 is 16, and if I times 16 by negative 16, I have negative 256. Okay, so this is the discriminant, and remember it's positive, so this has to be greater than 0. Okay, so we're trying to solve this quadratic inequality. So let's say this here, c squared minus 256, is a quadratic equation. So for example, y is equal to c squared minus 256. It doesn't matter that we're using c instead of x, okay? Now if I wanted to work out where this equation intersects the x-axis or the c-axis, you would put y equal to 0, and then you would solve this equation. Okay, so if you're solving this equation, you can either factorize or you can add 256 over to the left. And if you square root 256, you get 16. So c is equal to positive or negative 16. So if you were drawing this parabola on a graph, it's positive c squared. So the parabola would be this way up. Had it been negative c squared, you would draw it the other way around. And we're saying that the points of intersection along here would be positive and negative 16. Okay, so that's if it's equal to 0. But when you compare it with the inequality, we can see that it's actually greater than 0. So the part on your graph that you're interested in is above the x-axis. Okay, so all of this part. If it had been smaller than 0, you would shade everything underneath the x-axis. Okay, so if these are our values of c, so when c is 16 and c is negative 16, everything to the right is when c is increasing, so when the values of c are greater than 16. So that gives us our first inequality. The other answer would be over here, okay, and so this is when c is negative 16. Because we're moving to the left, this is when c gets smaller, okay, so the other answer would be c is smaller than negative 16, okay, so they are the set of values of c. So in the next question, we're given the equation of a curve up here, and in part A, it says that there's a line, y equals 2x plus 3, and this is a tangent to the curve. We need to work out the value of k. So whenever a straight line is a tangent to the curve, we know that the discriminant has to equal 0. Okay, so b squared minus 4ac is going to equal 0 in this question. So remember, the straight line intersects the curve in one place. So to find the point of intersection, you would solve the simultaneous equations. So both of these equations are rearranged so that y is the subject, and since y is equal to y, we know that 2x plus 3 has to equal all of this up here. So I'm going to use that to write down my first equation. So 2x plus 3 is equal to 2x squared plus kx plus k minus 1. Okay, so I'm just solving the simultaneous equations to start with. Now I'm going to rearrange this equation to equal 0 so I can find my values of a, b and c to work out the discriminant. Okay, so I'm going to move these terms here over to the right hand side. So remember, they're going to change sign when they move across the equal sign. So I'm left with 0 on the left hand side. Then I have 2x squared plus kx from before. Then I'm going to write down my minus 2x. Then I have positive k. And if I subtract 3 from 1, I get negative 4. Okay, next I'm just going to factorize here. So I'm going to factor out the x term so I can find my value of b a bit more easily. So if I do that, I'm going to have x in front of the brackets. And inside the brackets, I need to have positive k minus 2. And then I have k minus 4 at the end. Okay, so from here I can see my values of a, b and c. A is always the coefficient of x squared, so a is positive 2. B is the coefficient of x, so everything inside the brackets here, k minus 2. And c is the constant, everything without x, so k minus 4. Okay, so next we can work out the discriminant, b squared minus 4ac. So instead of squaring b, I need to square this because this is b. So k minus 2 all squared is the same as b squared. Then I'm going to write down minus 4, and I have to multiply by a, which is 2, and multiply by c, which is k minus 4. Okay, from here I'm just going to expand the brackets and simplify. So if I square these brackets and multiply them by themselves, I get k squared minus 4k plus 4. Here, if I multiply minus 4 by 2, I get minus 8, and if I times that by k, I get negative 8k. Then if I multiply negative 8 by negative 4, I get positive 32. And I can keep simplifying. Okay, there's only one k squared term, so that stays the same. Here I can add the k terms, so minus 4k minus another 8k is minus 12k, and if I add 4 and 32, I get 36. Okay, so from here, this is the discriminant. Now we need to put it equal to 0, remember, because the straight line is a tangent to the curve. The discriminant always equals 0. So we're solving this quadratic equation. So you could use the quadratic formula, or if you like, you can factorize this one. Okay, so if I factorize, I have k minus 6 multiplied by k minus 6 is equal to 0. So you can see there's only one value of k, which is positive 6. In part B, it's now given that k is equal to 2, and we have to express the equation of the curve in this form here, okay, so in completed square form. And from there, we have to state the coordinates of the vertex of the curve. So the vertex of this curve here is going to be a minimum point, like that. So we need to work out the coordinates of that point. So let's start by substituting this information into the equation of the curve. So I'm going to replace the letter k with 2. So if I do that in this equation, I get y equals 2x squared plus 2x, and if this is 2, take away 1, it becomes 1. So that's the equation of the curve now. We have to express it in this form here. So the method I'm going to use here for completing the square is I'm going to take the form that they've given in the question and I'm going to expand it. Okay, I'm just going to write it out here to start with. So I'm going to expand these brackets. Afterwards, I'm going to compare the coefficients of the new form with the original equation here, okay? Because remember, we're rewriting the equation in a different format. They should be equal to each other, so I'm going to compare their coefficients. So let's just expand this. Remember, this is squared, so it means I'm multiplying the brackets by themselves. So if I multiply those brackets by themselves, I get x squared plus 2ax plus a squared, and then not forgetting the plus b. And afterwards, I'm going to times everything by 2, so I have 2x squared plus 4ax plus 2a squared plus b. Okay, so I'm just expanding the new form. So this has to equal the equation of the curve. So let's just compare the coefficient of x squared. Here it's 2, and here it's 2, as expected. Now let's compare the coefficients of x. So here we have 4a, and here we have positive 2. They need to equal each other. Okay, so I'm going to form an equation, and I'm going to put that 2 equal to 4a. And if I divide both sides by 4, I work out that a is equal to a half. Okay, so I've worked out the value of a here. This is a half. Let's keep going and try and work out the value of b. So this time I'm going to compare the constant, okay, so the terms without x. So this 2a squared plus b has to equal positive 1. So I'm going to write that equation down. So 2a squared plus b is equal to 1. And remember, you just worked out the value of a. A is equal to a half. So you can replace this value of a with a half. So that 2 multiplied by a half squared plus b is equal to 1. I'm just going to carry on over here as I'm running out of room. So, alright, so let's work this out. So if I square a half, I get a quarter. So 2 lots of a quarter plus b equals 1. And if I multiply a quarter by 2, I get a half. And then from there you can see the value of b has to be a half. Okay, so we worked out the value of a is a half and b is also a half. So if you're writing the equation of this curve in this form, just to summarize, instead of y equals 2x plus a, we've got x plus a half because a is a half. Square the brackets, and then instead of plus b, we've got plus half. Okay, so you're just replacing a and b with a half. So we've written the equation of the curve in the form given. So here's the equation of our curve in its completed square form, and we're trying to work out the coordinates of the vertex, okay? So in this question, the minimum point on the curve. So at this minimum point, the coordinate of y is at its smallest. So if we're trying to work out the smallest value of y, we're trying to work out the smallest value of all of this. And if you consider square brackets, the smallest those square brackets can ever be is 0. Okay, if you imagined a negative number within the brackets, when you square it, it would become positive. So the smallest square brackets can ever be would be 0. Okay, so let's say there's 0. 2 multiplied by 0 is 0, which leaves us with y equal to a half. So that's the y coordinate of the vertex. Now, I just said it was at its smallest when the bracket is equal to 0. So if x plus a half is equal to 0, we can work out the value of x. If I subtract a half, I get negative a half. So that is the x coordinate. Okay, so that's it. So the coordinates of the vertex are here.